Hello, we're going to prove the following fact in this video. If H is the subgroup of G, which has an unusual fact, if HA is not equal to HB, then AH is not equal to BH. And we're to prove that gHg inverse is a subset of H. Well, you need to understand that if HA is not equal to HB, if that implies that AH is not equal to BH, okay, let's erase the if. I could negate this and put it first, contrapositive. This means that if AH equals BH, then this statement here is not true. It's not true that HA and HB are not equal. Oh, you mean they're equal? So basically, I could erase this because that's how we're going to think about it. And I'm going to put AH equals BH. If that, whenever that's true, then HA equals HB. Whether you formally write it or not, it is a true statement. It's called contrapositive. Okay, so we're going to prove this fact instead. So let's get into the proof. Now, we'll do this by contradiction. We want to prove that this is always a subset of H. So, suppose there exists a G in G and an H in H such that gHg inverse is not an element of H. Is not an element of H. Okay. So I want to show that, I'm going to end up showing that, you know what, I'm wrong. This is in H. Okay, consider GH equals G times an element of H times H. Okay, this is just H. But now I'm going to think of this slightly differently. I'm going to think of this being the element that I'm multiplying by capital H, and this is the element. G composed with H is one element, and I'm going to be multiplying that by H. Well, what we know about this group is that whenever we have this, we have that. So I can put this G on the other side. HG is equal to, and likewise I can put the GH on the other side. It's all about the ordering now, because now I can bring this G over. This line here implies that H is equal to H times gHg inverse. And if you multiply a subgroup by any element in the bigger group and you get back something in the subgroup, that's because this is in H. Well, wait a minute. We said that there does exist a G and an H such that gHg inverse was not in H. Oops, I was wrong. That implies that gHg inverse is an element of H for all G and G, H and X, H and H. That's enough. Or you can go that gHg inverse is a subset of H. And that's it for all G. There's no reason to say for all little h and h, because this statement doesn't have any little h's. Okay, that completes this proof. As always, if you're into watching mathematical proofs, you should seriously consider subscribing to my channel. Please leave a comment. Click the like button. See you folks in my next video. Watch and learn.